That way you guys have your video on YouTube. All right, so writing linear function. So there's two ways of writing it down. I'm going to use the example of selling cats today, if I get it a chance. Let me plug in my laptop. I'm totally like not ready for class, guys. I'm sorry. But there we go. All right, writing linear functions. In this lesson, you will write linear functions. Really, I couldn't tell. And functions with two variables. Graph them to display their relationship. So when we're talking about linear functions, we're talking about something with a constant rate. So we've kind of done this in other lessons. Let me turn this on real quick, where it's something like dollars per pound. And then we want to figure out how much money we're spending. So the amount of dollars is equal to dollars per pound, our rate, times how many pounds we're buying or something like that, plus some other constant. So that's our y equals mx plus b. So that's how we usually view lines. This constant rate, which is our slope, how we move on the graph, and this is how we begin on the graph, our y-intercept. So we're going to learn how to write these down. There's also the one where it's like if I think I did t-shirts and socks, like how many t-shirts did you buy plus how many socks did you buy times the price. So this is your socks. This is the price of socks. This is the price of shirts. This is the number of shirts. And this is like your budget, whatever you have for your budget. So that's another way of writing a function. So let's get into this. So forms of functions. So situation one, Lakeville, Melinda's television cable bill is $50 a month. So this is how much she always pays. This is our C. Or I should say, just like keep it all in the y equals mx plus b. So our formula is y equals mx plus b. So that's our b. And then it's going to be $150 for every movie. That's really good. I want to get her cable service if she only pays $150 for every movie. And her bill comes out to this much. So this is going to be our y. So we're going to solve for x, meaning that how many movies did she got? So right now, our m is dollars per movie. I think Alyssa just wants to go to Canada because she wants to escape Trump. And sorry for the YouTube viewers that have no idea what we're talking about. All right, so what we're going to do next is there's another situation where someone's paying $60 a month, but they're only paying this much per movie. So that's their M, and this is their B. So there's going to be a point where the first line starts off higher, but the other one is lower but has a higher rate. So eventually they will cross, and we'll get to that sooner or later. So what we're going to do here is like, what were the models, these two situations with equations, solve the unknowns? What similarities do they have? Can you solve the unknowns? So in this case, our unknown is number of movies. So both of them, so both functions, we don't know the number of movies. I'm not being mean today. I'm just being lighthearted. You guys were depressing. I have to psychologically shield myself from all the depressingness you guys put on me. All right. So both movies. They're both movies. Ah, see, you guys got me all messed up now. Both equations have an unknown number of movies. They each have a flat rate. So when we talk about flat rate, we're talking about our constant. That's the thing that doesn't change. It's going to be that much every day. Um, the next one is a price for movies. Price for each movie. So depending on how many movies you guys are buying, that's what's gonna happen here. So the flat rates are all different. So flat rates are all different. So you can even say, do we have to do the differences? We do have to do the differences. So the flat rate is flat rate and price per movie. Price per movie are different. Yes, we can solve for the unknown because like, can you solve for the unknowns in both equations? Yes, we can solve for them using y equals mx plus b. They didn't ask us to solve for them, did they? If they didn't ask us to solve for them, so I'm not going to ask you guys to solve for them because they should have asked us to solve for them if that's what they wanted to do. They just asked if we can. Yeah, we can. They didn't tell me to solve them. All right. So our introduction here. So Ethan shares a birthday. Ethan or Olivia and her brother Ethan share a birthday. So she's 5 years older. So she's always going to be 5 years older because it's the same birthday. In this relationship, the quantity changes at the same rate. So this same rate, they call it a ratio. Every time you see ratio, just think fraction. All right. And that fraction is our slope. So there's several ways we can think of slope. Slope is our rate of change. The symbol for slope is m, the letter m, and slope is our rise over run. So in that one equation that we did on Brianna's brother, so she sells cats for $30 and he already had $50. The $30 per cat is our rate of change. So that's our slope, 30 over 1. I'm just teasing Brianna. Watch next week, Brianna's not going to be here. Uh, we often come across situations where one quantity changes consistently. These relationships are linear. So, linear meaning that it's the same rate over and over. So, that's what it means by linear. It's always going to be the same slope. Brianna's brother is always going to sell cats for $30. Forms of linear equations. All right, so let's get into the forms of linear equations. So forms of linear equations. So it's this idea of the independent variable and the dependent variable. I don't know why we're going over this because we have gone over it before. I'm not hating on anyone. I'm just bringing more personality to the learning. I bet she's gonna remember slope now. She's like, slope is always $30 a cat. So the independent variable is what we can't control. Usually it's like time and things like that. And then the dependent variable is usually something like money. It changes based on the amount of time that we're using. So we've done that in other lessons. They're just kind of describing it a little bit more now. So now we're going to learn about the different forms. So this is our standard form. So this one shows us our rate of change right here, and it shows us our starting point right here. So this is our B. I'm going to try to remember to use yellow for our y-intercept. I'm going to try to remember to use orange for M. So just remind me, guys, in case I forget. And then our standard form is a little different. This is the one where I keep using the t-shirts and socks option. So for example, this is the cost per sock, and this would be the cost per shirt. I don't remember what order I had them in. The next one is our point. You won't. I'll just have to use that example more often than Brianna if you're not going to remember it. So this one right here is telling us a point. It's telling us a y value. And this other one is telling us our x value. So it's a point on there. So in this case, Brianna's brother sold 2 cats for only $7. So that's a point. And the rate at which he's selling it is right here. So it's 3 cats for $2 is the rate they sell. So Brianna's brother probably had some money left over when he was doing this. All right. So moving on. So then we're going to look at how to do the rest of these. All right. So point slope form. So point slope form is that one where we have the y minus y1 equals mx minus x1, where x1 and y1 are a point on the slope. So here, the only one that matches that description is this one. It has a point here, a y coordinate here, y value, and an x value here. And our slope, our rate of change is right there. So I'm going to move that here. Standard form, again, that's our sock and t-shirt example. So it has the x times something right here and the y times something else right here, and it's going to equal a constant, meaning it has no other value. So I'm going to move that there. Slope intercept form, that's the one that has the rate and the constant, the y equals mx plus b. So the one I'm always going to talk about the most is the y equals mx plus b. And that's going to be the one where it's like cost per cat and then current savings. That'll be the last one, Brianna. I'm sorry. All right. So our slope. So our slope, again, is our rate of change. Our b is our y-intercept. So this is the form that I keep saying over and over and over again. And we can solve for our y-intercept if we already have a point by plugging in a y and an x. So y and an x is any y and x value that fit on the line. So it's not like negative 1/2 is the x. This is a form that shows us the relationship between the two. And we can also, so after we solve for the b, it's just saying, oh, cool, we solved for b, now we can make our formula. Because before, let me go back one. Before we didn't know what our b was, then we plugged in a point, and then we solved for b, now we can rewrite the formula. All right, so this is our point slope form. This is the one where you need to have your slope. So let's say you only have 2 points, no slope. You're going to have to solve for your point by doing your rise over run. That's this equation. In geometry, I focus more on my rise over run than actually calculating it. And you guys can do that too, but this is a good formula to remember. This is how we figure out our rate of change. Sorry, Brianna, one more. So this is how we figure out how much money her brother's selling cats for. Okay, that's it. I promise. I'm sorry. All right. So here, our standard form. This is our. I said it was the last one. I'm sorry. It was too easy. Standard form. This is the one where I said the socks and the t-shirts. I mean, I can do it more if you want me to mention it more. So the way we figure this out is we're going to have to plug in our point to figure out the slope. Why are they talking about slope? Oh, okay. If we're given 2 points, we figure out our slope. So they're saying that we can figure out our slope this way. So if we do that, we can go, okay, we need our slope for this. I don't know why, because it's standard form. It's really weird. What is Edmentum doing right now? Let me see their big picture first, because this is a weird way to teach it. Da, 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 da. All right. So I don't know why they want to do point slope form and then they want to rewrite it in standard form. Most of the time, you're either given a problem in standard form, unless it's a test, in which case they're going to test you on how to make standard form. So they're just teaching you how to get standard form from here. The main idea is just to get a number here, a number here, and a number there. Usually you want them as whole numbers. So if you have like fractions, like this, for example, y, you want to get rid of those by multiplying it by the lowest common multiple. In this case, 2, 3, and 6 all turn into 6. If we multiply them, they will all eventually share this 6 as a common multiple. I am just hating. I wish I had a cat. So that's how you would get rid of it, to have the whole number form. All right. So this one right here, it's saying we want to graph a line that goes through this point, and we want it in slope-intercept form. So slope-intercept form, this is the one that's y equals mx plus b. So the only one that we can do here, so we have to start off with figuring out our slope. So we have to figure out the change. Now we can do this with their formula. The change in x over the change in, or the change in y over the change in x. In science classes, they usually call it the delta for the change in. So another way of doing this that I like doing better is just going, how do I get from 3 to 8? Oh, I'm going to go up 5. That's my change in y. And then for my change in x, I'm going to go, how do I get from negative 4 all the way to positive 6? Well, if you look at a number line, negative 4 is here, then there's 0, then all the way over here is 6. So I have to move 4, then I have to move 6. So that means I had to go to the right a total of 10. So my slope, if I reduce it, is 1 over 2. It's 1/2. All right. Wait, are you saying I'm lying because I'm scared of cats, or are you saying that Hector's lying because he's scared of cats? Oh, she's scared of cats. All right. So we have the 1/2 here. Now, in order to figure out our b, we're going to have to pick a point. I don't like negatives, so I'm just going to pick the 6, 8. We can pick either one. So I don't like those negatives, so I'm going to pick this 8 equals our slope, which we figured out was 1/2, our x, so 8 goes here, and then this is 6. Our x was 6. And then we're going to try to figure out our b. So when we multiply this out, half of 6 was 3 plus b. So now we just take away the 3, take away the 3, and we figure out that our b is actually 5. So now, normally we would show our work, and Edmentum gets really picky when you show your work, but make sure when you're doing it on an activity to show your work. But this case, we can just do 1 half, and our b was 5. We're going to submit that. And then here, I should have just shown you guys this. They show you all the work anyways. But that's how we figure this out. We're going to have to use that formula. Or, like I said, I didn't use the formula. I'm just like, how do I get from 3 to 8? That's the easiest way I know how to do it. Modeling a linear equation. So for modeling, we're going to do, remember these people? They were the same age. So we're going to say that our slope is 1 because they go, every year they get 1 year older. So 1 year per year that passes, obviously. And we're going to say that Ethan is exactly 5 years older. So Olivia is y equals x. But Ethan, they age the same rate. So they go up the same rate. So they have the same slope. But Ethan, we have to add 5. So his graph is going to be 5 higher when we're talking about age. He starts off with a 5-year difference. So that's where we get Ethan's thing. So he starts off at 5. Every 1 year, he goes up 1. Or if you want to do rise over run, you can look at his up 1 over 1. The graphs representing Ethan's age. So this is the domain range. So domain, the way I always remember domain and range, because it's important, you guys will have that question later. Domain in alphabetical order comes before range. Well, our x comes before y. All right, so if we're looking at something else, so in this case, look at another real life example. So in this case, the y-intercept is, we know that the negative slope. Okay, so this one, we're going to be using up water. So there's water in the tank, and the slope goes down 150 every hour. So every hour we go down 150. So that means in 2 hours, we go down 300. So we can see that here. We went down 300 for 2 hours, which is the same thing as 150 every 1 hour. So it's just a simplified version of it. This is why I like using like 2 points, because you can also solve this by doing, what was it? 600 minus 900 over, since this is at 0, we're going to say 0. So 2 minus 0. So we get negative 300 over 2. Now, why is this negative? Because it's a negative slope. It's going down. So that's why the formula works. It also works if you do it backwards, by the way. Let's say I didn't call this 1. Let's say I called it 2. If I do 900 minus 600, I'm going to get 0 minus 2. So I get 300 over negative 2, which is still negative 150. All right, so moving on. Again, always check out these videos. They're pretty useful. They give real life examples too. All right, so 20. George rented a cab and is sightseeing. The cab charges $9 to pick up his family. So this $9 doesn't change. It's our constant. It's not like if he drives more, they charge him more to pick him up. So that's our B, in other words, our B, our constant. The next is per mile. So in other words, we have dollars per mile. This is our slope. So when we're doing this, we have y equals 0.25 cents because it's $0.25. So that's why you have that decimal, times x, where x is the number of miles. So when we multiply miles by dollars per mile, we only get dollars. That's why they cancel out. We have dollars per mile, multiply it by miles, and we're adding another dollar. So our answer, our y, is going to be in dollars. And this is going to be plus our $9. So that's going to be this one right here. Now let's see which graph. So we start off at 9, and every 4 miles, it's going to be $1, right? Because if we do this for 1 mile, it's only a quarter. But if we do 2 miles, we get 50 cents. So we want to do 4 miles. The only reason why I want to do 4 miles is I want to see it increase up. So we start off at 9, and in 4 miles, we should have gone up $1. So 1 mile, 2 mile, 3 miles, 4 miles, we went up $1. So this has to be our answer. I skipped this one because it didn't make any sense. This one, every mile we kept going up $1. So that's $1 per mile. It's too much. So that's how come I skipped it, in case you guys were wondering. See, this is why I bring up the cats, because Brianna doesn't like talk when I don't talk about cats for some reason. It's true, you're not engaged, but at least I know you're paying attention. Lisa brought 2 pounds of apples and 4 pounds of pears for $20. So it's 2 times the cost of apples plus 4 times the cost of pears equals 20. So when we do this, this is what's known as standard form. I kind of gave it. Oh, I'm sorry. That's a good point. I'm going to stop doing that. So that's why we're getting this right now. So they're getting the exact same formula I wrote down. So here, they're going to say like, hey, we found out how much the pears cost. All right, so, or the apples, I'm sorry. So we found out how much the apples cost. If we know how much the apples cost, we can plug it into here, our x. Our x was cost per apples. So we can solve for y, which is our cost per pears, by doing all the work. I'm not going to really go over the algebra thing. You guys can see it here, but we've been practicing it enough. You guys are just learning what it means now. All right, so our next one, notice how we're representing it. So this is kind of weird how we have it set up. So in order to switch it from standard form to this form, we can just solve for y. We're going to isolate y, get y by itself, isolate y. So we're going to move over the x, then we're going to divide by 4 at the end. All right, so moving on to here, how do we solve for slope? It's our change in. What's our change in y? Our change in y is 60. What's our change in x? 3. So it's 60 over 3. So that's what they're doing right here, except they're doing the subtraction, and then they simplify to get that 20. And then if we want to figure out the equation, we can use point slope form by doing this. If you guys don't like point slope form, you can always use standard form, y-intercept form. We're going to do this, plug in any y we see here, and we're going to plug in the x that goes with that y here. Like, it doesn't help if they're both in the same color. It has to be the same one. You can't pick and choose. You can't be like, I'm going to pick this one, and then I'm going to pick this one. They have to correspond to each other. Otherwise, you're not going to get the right relationship. All right, and then we can check out a video on it, but this whole class is basically a video. So again, watch that on your own time. So let's get to the task. So here, Jessica has $24. She wants to spend all of it at the grocery store, and she wants to buy carrots. So our carrots are $2 each. So it's $2 each for carrots, and then our bagels are $3 each. So we're going to have this plus $3 per y. And this is going to equal our $24. So this ends up meaning that x is number of carrots and y is the number of bags of bagels, I guess. I would be buying chips, honestly. Wow. Okay, so then we'll cross out this and we're going to say chips. Does anyone else have something else they want to shop for instead of carrots? Well, we need to have two examples, not just chips. And Arizona drink. Okay. So then this is going to be Arizona drink. Okay, so our X is our Arizona drink. And then our Y is the number of chips we're buying. All right. So when we're doing this, we're going to try to figure out how much we can. That's expensive. Like $3 for chips? But all right. So we have $24 to spend on Arizonas and chips. Oh, that's true. A big bag of chips would cost like $3. That makes sense. Big bags of chips and I'll say a pack of Arizonas because Arizonas aren't $2. I hope they're not. So when we're solving this, we're going to put the $2 for a pack of Arizonas and we're going to put $3 for our chips and we have these $24 to spend. So let's say we wanted to figure out how many bags of chips we can buy depending on how many Arizonas we buy. So this one, we're solving for how many chips based on number of Arizonas that we buy. So that's how we're filling this out. So the way we would fill it out is we're like, well, how do we figure out how many Arizonas we can buy? I don't know. Just get the Arizonas by themselves. All right. So what we're going to do is we're going to move over. Oh, wait. I did this backwards. Oh, wait. So how do we figure out how many chips we can buy? You guys messed me up with the different things. All right. So we're solving for y, how many chips we can buy. So we're going to have to move over the Arizonas. I only said it a little backwards. So now we have, well, we can buy 3 Arizonas depending on if we buy this. Oh, my bad. That's a negative, and this is plus 24. And then what we're going to do is we're going to do y equals negative 2 over x plus 24. So this tells us what's happening here. So basically, every time we buy every time we buy 2 Arizonas, we can no longer buy 3 chips. So for every 2 Arizonas that we buy, we take away 3 chips that we can buy. So that's our slope right here. So for every 2 Arizonas, we're losing out on 3 chips. Or we can look at it backwards. If we buy 3 chips, we're missing out on 2 Arizonas. I might say that backwards, but you guys kind of get the idea. Oh yeah, I am saying that backwards. I was like, wait, but chips are more expensive. Yeah, so every time we buy 2 chips, we miss out on 3 Arizonas. Duh. Because if this is Arizona, it's going to cancel out with the Arizona on the bottom. Because it's 2x over 3. So for every 3 Arizonas, we're missing out on 2 chips. Now I'm hungry. You guys made me hungry. I'm going to eat all kinds of junk food now that I shouldn't be eating. So if she buys 4, let's fix this right here. So if she buys 4 bags of chips, she will be able to buy, we did say chips was that right? So if she buy 4 bags of chips, she can buy 6 Arizonas. All right. And this is how you solve for it. Like, well, I'm going to buy 4 bags of chips. All right, well, how many Arizonas can I buy? Well, I'm going to plug in the number of bags of chips right here. And then I'm going to solve for X, which we know are our Arizonas. You're going to have a lot of extra drinks. All right, so now how do we graph that? Well, we're going to start off with this 8. So 8, what does 8 represent? So 8 would represent the maximum number. So if we pretend that this isn't here, if we pretend that we don't have any Arizonas and we're only buying chips, that means we can buy 8 chips with no Arizonas. So we're going to put this here, 8 chips, 0 Arizonas. And what we can also do is, now that we have this 8 chips with no Arizonas, we can go down to, so we're not buying 2 chips, but now we can buy 3 Arizonas. And then we can, like, oh, well, you know what? I want less chips, which I doubt anyone will ever say that. But we're going to go down 2 more chips, and we're going to be able to buy 3 more Arizonas. And we're going to keep doing this over and over and over again until we find out that it's like, oh, cool. If I don't buy any Arizonas at all, I can buy, or I'm sorry, if I don't buy any chips at all, I can buy 12 Arizonas. So depending on how you want to shop, you have all of these options here. And they eventually make a line. So let's say let's say Jasmine only wants to buy Arizonas. She can buy 12 Arizonas. Let's say Alyssa only wants to buy chips. She can buy 8 chips. And let's say somebody in the middle, like myself, I want some Arizonas with my chips. I could probably go like, oh, I'm going to buy, well, I want more chips than Arizonas. So I'm going to say I want 3 Arizonas for my 6 bags of chips. Don't forget to practice social distancing while you're out. So this is saying, like, now that we have our graph, it's, oh, I don't know why they're doing a point. This is weird. Oh, well, they already kind of did an example. So somebody else was like, I want to buy I want to buy 6 Arizonas. So they're going to be able to buy 4 bags of chips. And then just write down how much you understood this. You can also write down how much it helped that I was talking about Arizonas and chips instead of carrots. And what was the other thing? Carrots and bagels. Why would you buy carrots and bagels? That doesn't even make sense. Our example makes way more sense. So weird. Carrots and bagels. All right. And then as always, guys, make sure you're looking at your summary. Your summary is going to teach you all about graphing and doing this. I'm going to stop the recording. I don't know why I always click a new one.